All right, this is our last self-assessment exam or self-assessment to see how you are on the material that we have from 9.5b through 10.5. The first instruction is identify any transformation to the base graphs of sine or cosine and sketch the function. Don't forget that we have y equals a, either sine or cosine. I'll just put sine in there. And we have b times x minus h plus k. If there's nothing in front of x, then we don't have to worry about b. And that's the case in this first graph. So let's take a look. I have a 2. I have an amplitude of 2. I have shifted up 1. I don't have to factor anything out. I'm in the format that works for me. I know I have gone to the left pi over 3, and I have a period. This is not a transformation, but I like to write it so I know what I'm working with, 2 pi. The other thing I like to do is make sure I understand how much each one of these tick marks is. There is 6 tick marks between 0 and pi. So every tick mark equals pi over 6. Now let's graph. I want to draw my center line. I have to go up 1 unit. So this is my center line. This is a cosine graph. Cosine on a unit circle, if I start at 0 degrees, is my x value, and that's at 1. So normally I would have started at 1 unit above my center line. And in this case, I'm going to be 2 units above my because my amplitude is 2, but I also have a shift, and I have a shift left pi over 3. Pi over 3. So how many tick marks is that? That'll be 2 tick marks because 2 pi over 6 is the same as pi over 3. So that's where I'm starting from. I also know that my period is 2 pi, so I go find 2 pi and I will move over pi or 2 tick marks. And there's where I should end up. Now, how many tick marks do we have between 0 and 2 pi? If you counted those would be 12 tick marks. So I'm going to take 12 divided by 4, and that gives me 3. So I'm going to break that sine or cosine graph up into 4 parts. So I'm going to have a data point every 3 tick marks. So let's go ahead and start. So I go 1, 2, 3 down to my center line. 1, 2, 3. I go 2 units below my center line. 1, 2, 3, back to my center line. 1, 2, 3, and I'm back to where I started from and at where I expect it to be. And then I'll just do one more. Back here, 1, 2, 3, and that'll be good enough. All right, and then do your best to draw a curvature and then show maybe arrows because it is periodic and it'll continue on and on. All right, next one. Notice, again, if I have something that's multiplied by b, I need to factor it out so that I can get it into a format where I can quickly identify each one of my transformations. I need to factor out that 2. So y equals minus sine, and I'm going to factor out that 2. Factoring just means divide. So if I divide 2x by 2, I'm left with x. If I divide pi over 2 by 2, I'm left with pi over 4. Now I know my h value. That was the point of doing that. So I'll go ahead and identify everything that I've got. I have an x-axis reflection. I have down 2. I have a shift right pi over 4. And now I got to find what is the period of this graph. So 2x, 2 is my b, and normally my base period is 2 pi. And so what is my period now? It is just pi. And so I solved for what that period is. Okay, so this is a sine graph. Sine on the unit circle is my y value. So as I start, I will start at the y value of 0. So let's go ahead and find our center line. And we will start at the center line for sine. Except we will not, we have to shift it right, pi over 4. Every tick mark is worth pi over 4. So we're going to shift it 1 tick mark to the right. So here's where I'm going to start. I know my period is pi, so I'm going to go and move that over 1, 2, 3, 4 tick marks. 4 pi over 4 is pi. And I have an x-axis reflection. So normally pi goes up, but because I have an x-axis reflection, I'm going to start downward. So let's go ahead and draw that. My amplitude is just 1. Okay, so one tick mark over, go down 1 tick mark over, back to center, 1 tick mark over, up 1 unit, 1 tick mark over, I'm back to where I started from. 1 tick mark over, I'm down 1 unit, 1 tick mark over, center, tick mark over, maximum, tick mark over, back to center. That's plenty. Go ahead and draw a nice smooth curve for a sine graph. Add some arrows to indicate that it goes on forever because it is periodic. And there's your graph. Next one, write an equation in the form of y equals a times sine bx or y equals a times cosine. You could have picked either cosine or sine. I'm going to go ahead and pick this graph right here, which is cosine, because I have started at something above my center line. My center line is at my x-axis. I'm going to go ahead and take a look at my amplitude. Amplitude is always a positive value. So it looks to me like the amplitude is 5. So we know that value is 5. Let's go ahead and take a look and see what the period is here. We have a period of 8. So this is my period. 8 equals period. And so I got to find the value of b. So b times x is equal to 2 pi. I don't need to find my x value. X is the period. So I know the period, which is 8. And so this time I'm solving for b. 2 pi over 8, which is equal to pi over 4. So now we know the b value of pi over 4. So we were asked to write an equation. So we need an equal sign in that. So y equals, the amplitude is 5. This is cosine based on what I chose. B is pi over 4, and I will have x. You do not need parentheses, even if you had something else to add. It is not wrong to add parentheses. It's just not necessary. So there is your answer. You could have also written a sine graph, by the way, if you wanted to. Maybe you would have started here, then you would have a shift left. But notice they actually gave us this format. So we didn't have the ability to shift left. So actually, there was only one answer for this one. Now you have a freedom, write an equation to describe the given sinusoidal function. There's more than one answer. I could, let's see. First thing I like to do is identify where my center line is. And so how do I do that? I count what's the distance between the max and min. So I have 1, 2, 3, 4, 5, 6. There are 6 tick marks. I'm going to divide by 3. 1, 2, 3. So my center line is at 1. So I have an up 1, and I also have an amplitude of 3. Okay, so I know an amplitude of 3. Doesn't matter which one you pick, as far as sine or cosine, you will have an amplitude of 3. And also, doesn't matter which one you pick, you have shifted up plus 1. Okay. All right. Yes. Okay. Let's go ahead and do, I'm going to pick cosine. So I'm going to, actually, I'll pick sine first. I'm going to pick sine. So I start at the center line. Okay, and so let's write out our function. Y equals a sine of b x plus, sorry, x minus h plus k. And so we just found a to be 3. We know that k is 1. Yep. How much did we shift to the right? Well, what is h? We shifted 1 tick mark. What is each tick mark worth? This is 2 pi, and I have 4 tick marks between 0 and 2 pi. So 2 pi divided by 4 equals pi over 2. So every tick mark is pi over 2. So I shifted over pi over 2. So that is h, pi over 2. Now we got to find the value of b. B, I got to find the period. So how do I find the period? I go from here to here. I can count the number of tick marks I have. 1, 2, 3, 4, 5, 6, 7, 8. So the period is 8 times pi over 2, which is equal to 4 pi. And if I know the period, I can solve for b, right? How do I find b? I know that b times the period is equal to 2 pi. I solve for b, I get 2 pi over 4 pi, which will equal 1/2. So we just found the value of b. Now I can write my graph or my equation. So y equals, come on, y equals 3 sine 1/2 x minus pi over 2 plus, what do we find k? 1. If you chose, let's say, cosine, I'm going to pick this spot. What if you picked this one? That would have been y equals, amplitude is still 3. It's not an x-axis reflection because I started at the top and I still went down. That is cosine. The value of b is still the same because the period didn't change, x. The only thing that's different is that we shifted the graph to the left, and we shifted it 1, 2, 3, 4, 5. We shifted it to the left 5 pi over 2. So we would have positive 5 pi over 2, and we have plus 1. So we could have also written it as a cosine graph. Either one. All right, in most of Europe, electricity is supplied with a peak voltage, that's important, of 310 volts, with a frequency of 50 hertz. Write a sinusoidal function, V of t. Okay, that could use to model the voltage seen at an outlet if the peak voltage occurred at time equals 0. Let's write some things down. I have peak, that's my maximum point on the graph, of 310. I know that the frequency is equal to 50 hertz. That means that the period is 1 over 50. Period and frequency are inverse of one another. So the other thing that we learned in that discussion was that the peak voltage occurred at time t equals 0. So I'm at the top at time equals 0, and then I'm going to do something like that. So we have a cosine graph. So the amplitude is my peak, which is 310. And then I have a cosine graph. I don't need a parentheses, so cosine. And then I have to have, so let me just write off the generic equation over here. V of t is equal to a times cosine b of t. We're not going to have a shift up or right because we're starting at time 0. And so we have to find the value of b. Well, we know the period, so we got to find b. So b times x is 2 pi. We know that the period is 1/50, and we will set that equal to 2 pi. We will find b to be 100 times pi. And so we can go ahead and plug that in, 100 pi, and then we have to have our variable. In this case, it's t, not x, because that's what they told us. Didn't have to put those parentheses, but I went ahead anyway. I just like it for clarity, but you did not have to. Excuse me, because they're all multiplied by one another. So that is my answer. B of t is equal to 310 cosine of 100 pi times t. All right, find all the solutions of the equations on the interval of 0 to 2 pi. We need exact answers, which means you're not going to use your calculator. So what we're going to do is we're going to isolate our trigonometric function. We will rearrange this equation. We'll get rid of the 1 on the left-hand side by subtracting 1 from both sides. That'll become 4 cosine theta is equal to -2. I'm now going to divide both sides by 4, and I will get -1/2. This is where you'll need to either know your unit circle or refer to your unit circle. Cosine again is my x value. Where is my x value negative? That's going to be in quadrant 2 and 3. And again, this is my short side of my 30, 60, 90. My short side's 1/2, my long side is square root of 3/2, and my hypotenuse, which is my radius on the unit circle, is 1. So where does that occur? That occurs here and here on my unit circle. And so what angles is that? Again, having memorized your unit circle, that is going to be 2 pi over 3, comma, and the second one is 4 pi over 3. In the quadrant, second quadrant, you subtract 1 from the denominator. In the third quadrant, you add 1. Next one, I have tangent. I'm going to isolate the tangent theta by itself. I'm going to add 1 to both sides of the equation. When I do that, this will simplify into square root of 3 tangent theta is equal to 3. I will then divide both sides by square root of 3. That will become 3 square root of 3. I'm going to get the radical out of the bottom by multiplying both top and bottom by the square root of 3, and that will give me that'll give me 3 times the square root of 3/3, which will just simplify into the square root of 3. So I have tangent theta is equal to the square root of 3. You'll have to refer to your unit circle. Again, tangent is y over x. Where do I have square root of 3 divided by something such that I end up with just the square root of 3? And that will be located at this location. Let me just go ahead and find them. This right here is my short x, which is 1/2, and this is square root of 3/2. This right here, tangent's positive, so it has to be in the first. So tangent theta is a positive value. That has to be in the first quadrant because x over y has to be positive. It can also be in the third quadrant because both x and y are negative, which becomes positive. And this is negative. This value is -1/2, comma, negative square root of 3/3. And if you take y over x, you'll get the square root of 3. And so the values for the angle is pi over 3, comma, 4 pi over 3. It is my understanding you're getting a unit circle on your test, but you may have to find your tangent values. All right, the next one, cosine, this is a quadratic, by the way, 2 cosine squared x minus 1. Please pay attention. This is not x squared. This is cosine squared of x. That is the same as cosine of x times cosine of x. That is equal to cosine squared of x. I can Okay, sorry, I got interrupted. So here's what we're going to do. We're going to isolate this cosine squared of x. So I'm going to add 1 to both sides of the equation. Cosine squared of x is equal to, add 1 to both sides. That'll give me 1. Then I'm going to divide both sides by 2. Cosine squared of x is equal to 1/2. How do I get rid of a square? I take the square root of both sides. So that will give me cosine of x is equal to, please do not forget that when you take a square root, it is plus or minus. So you will have plus or minus the square root of 1 over square root of 1/2. That actually will simplify into cosine of x is equal to plus or minus the square root of 2 over 2. How did I get that? Square root of 1 over the square root of 2 is equal to 1 over the square root of 2. And then I multiply the top and the bottom by the square root of 2 to get that. Okay. All right. Where on my unit circle do I have square root of 2 over 2? That is my sides of my 45-degree angle triangle. So that's going to be located here. There's a positive 1. This is a negative 1. This is a positive 1. This is a negative 1. And so this is going to be pi over 4, 3 pi over 4, 5 pi over 4. And this one I have to think about. That is my 7 pi over 4. If you recall, this is how I do that one. I take 3 pi over 4. It's straight across from that. I multiply by 2, the numerator. The numerator is the hard part. I add, that's 6, I add 1, that's 7 pi over 4. And so these are the value of that angle. All right, next one. This is quadratic with respect to cosecant. I have to find 2 numbers that multiply. Let's see if I can do that. I have to find 2 numbers that multiply to a -4. 2 times -2 is a -4. And add to a +3. Those values will be a +4 and a -1. And then I will take 2 cosecant of x, 2 cosecant of x, and then I'll divide by 2. That 2 divides out nicely on the left-hand side. So that will give me let's see if I can write cosecant while saying it. Cosecant x plus 2 times 2 cosecant of x minus 1, and all of that is still equal to 0. Now, either this side is equal to 0 or this side part of the equation is equal to 0. So I'm going to go ahead and set those equal to 0, and then we will solve them. I do not like dealing with cosecant. I'm pretty sure you don't either. So once I get it rearranged, so cosecant x is equal to -2, I would change that to sine by taking the reciprocal. Sine of x is equal to -1/2. And over here, we will get cosecant x equal to +1/2, which will mean sine of x is equal to 2. Sine actually is never equal to 2. It only goes between -1 and 1. So this is no solution. So now I need to focus on where is my, at what angles do I get a sine value of -1/2? That is what I'm looking for. Sine is my y. Where do I have negative y? That is going to be in my 3rd and 4th quadrant. That side is my short side. So I need a short angle. That's pi over 6 angles. This one's going to be 7 pi over 6. And this one's going to be 11 pi over 6. Yep, that's the answer. So x is equal to 7 pi over 6, comma, 11 pi over 6. Okay, one more to go. This one requires a calculator. Let me grab mine. All right, I got my calculator. So we have this equation right here that we're going to solve. And notice it says round your answers to the nearest 100. So we're not going to be using our unit circle to give exact answers. We're actually going to use the calculator to solve. We're going to take this equation, 3 secant of theta plus 1 is equal to 9. We're going to rearrange that so that I have my trig value on the left and some values on the right, because I need to modify this because I can't plug in into graphing secant. So I'm going to subtract 1. Whoops, sorry. I'm going to subtract 1 from both sides of the equation, and then I'm going to divide by 3. So I get secant of theta is equal to 8. Then I'm going to divide both sides by 3, and I will get secant of theta is equal to 8/3. I don't want to work with secant. I'm going to convert that to cosine by taking the reciprocal. So cosine of theta is 3/8. This right here is going to get entered into my calculator as y1. This right here is going to enter into my calculator as y2. So let's go ahead and do that. So y1 is on the top left of your calculator. You will then go and hit cosine, and we don't have theta on our calculator. We have the ability to hit x, which is the key to the right of your alpha key, which is just below second function. Then into y2, I'm just going to go ahead and put 3 divided by 8, which is just going to be a horizontal line at approximately just less than a half. So now we need to go and adjust our window. Our window needs to be between, this is x min is equal to 0, x max is equal to 2 pi. This reminds me actually that your mode must be in radians. Okay, otherwise your answer will not be correct. If you have a TI-84 CE version, you'll see that it is on the top bar of your calculator. If it is not, you need to hit mode and change that from degrees to radians. All right, so let's go ahead and check our window. 0, 2 pi, I left my scale as 1. I still have -3 as my y min, and y max I have as -3 and 3. What do I need that value to be? I have to be able to see this 3/8. This -3 and 3 will show me 3/8. I got to see that horizontal line. And then I can go ahead and hit graph. Again, your plots 1 and 2 and 3 need to be turned off. Otherwise, you'll see some other graph there that'll mess you up. All right, I have a CE version. I have color. So I can tell that one graph is red, one graph is blue. And so we have a box. I have a box that looks something like this. Close enough. And I have 2 solutions where it intersects. I need to go find the values of those intersections. So I'm going to hit second function and the trace button, which gets me to the calculate menu. And number 5 is intersect. I'm now on my first curve, which is blue. I'm now on my second curve. And I'm just going to go ahead and, for the sake of quickness, type in approximately 1.2. And sure enough, it found my first intersection, which is called theta. And that was 1.1. They said to the nearest 100th. So this would be 9. And then I'm going to go do it again because I need to find the second intersection. Second function, trace, which gets me to my calculate button. Option 5, which is intersection. First curve, my blue curve. Second curve, my red curve. Great. I'm good to go. Now I'm going to hit a, you can scroll over and get close to it. You've got to get close to it, or you can plug in a value. 2, 3, 4, 5. I'm going to just guess 5. And it gave me 5.096. So I'm going to round that to 10. And those are your 2 values. I hope that helped you with the material from this last section of our unit. We'll be repeating these tomorrow for our review for a test.